This conference will now be recorded.
All right, good. Hello, everyone. Welcome to the Satellite Book Club seminar series. The title of our talk today is an overview of the TROPICS mission. Our presenter will be Dr. Patrick Duran, research physical scientist from NASA Sport. And our facilitator today is Dr. Stephanie Stevenson, meteorologist and programmer from the National Hurricane Center. A few reminders before we get underway. This session is being recorded. As usual, we ask that Q&A questions be put, feedback be put into the chat. We'll be filling them at the end of the presentation. As usual, sign in with your full names, please, so that we know who's on the call and we can follow up with you as needed. And if you're not receiving our correspondence or stop receiving our correspondence, please check your spam folders, as we have found that some of our emails are going there. We look forward to future presenters. Please contact the TROPICS team if you're interested. We'd be glad to have you and help you host a presentation. And the training team, specifically Brian Mata, can help develop training materials that might be unavailable, or he can help you locate them. Thanks as always to the TROPICS team, Kashad Bowman in particular, Office of the Chief Learning Officer, GOES-R, JPSS programs, our facilitator speakers, and all of you participants. Before we hand over the mic to Patrick, just a few words about his background. Dr. Patrick Duran is a research physical scientist at NASA Marshall Space Flight Center and the Deputy Program Applications Lead for NASA's TROPICS mission. Originally from St. Augustine, Florida, Patrick received his bachelor's degree in meteorology from the Florida Institute of Technology in 2012. And a Ph.D. in atmospheric science from the University of Albany in 2018. After a one-year postdoc at the University of Alabama in Huntsville, he joined NASA Marshall in 2019 as the Tropical Meteorology Team Lead at the Short-Term Prediction Research and Transition, also known as SPORT. So Patrick, we welcome you to the Satellite Book Club, and please begin as soon as you're ready.
All right, thank you so much. Can you hear me okay? I think I'm coming through.
We hear you loud and clear.
Wonderful. Well, it's really great to be here. I'm very happy to be presenting to the Satellite Book Club. Thanks to Stephanie for the invitation, and thanks everybody for coming out to hear a little bit about our new TROPICS mission. So first, I'd like to acknowledge some co-authors who contributed to this presentation, including Bill Blackwell and Vince Leslie at MIT Lincoln Lab, Galena, Mark, and Deb, who many of you I'm sure know from CIRA, and also Derek Herndon from SIMS. So what is TROPICS? TROPICS is the time-resolved observations of precipitation structure and storm intensity with a constellation of smallsats mission. That's a big mouthful for a bunch of small satellites, so we just tend to call it TROPICS. And the constellation consists of 4 3U CubeSats, which basically means the CubeSats are about the size of a shoebox or a large loaf of bread. And they contain radiometers with 12 channels from 91 to 205 gigahertz. So you can actually see those TROPICS space vehicles right here on a shelf. This little gold foil thing up here is the actual radiometer, and then this is the little satellite bus down here. The really unique thing about TROPICS is that it's designed to provide high temporal resolution observations over the tropical regions of the globe with a 60-minute median revisit rate. So this is a significant improvement over currently available passive microwave radiometers that we have typically in polar orbit. So the primary products that TROPICS will provide are brightness temperatures, vertical profiles of temperature and humidity, total precipitable water, rain rate, and tropical cyclone intensity estimates. So the kind of things that you're probably familiar with from some of our other passive microwave radiometers that we currently have on orbit. So this presentation is really timely. It's coming at a very exciting time for TROPICS. We actually launched our first 2 constellation satellites this past Sunday. It was provided by Rocket Lab, launched out of New Zealand, and so they named the mission Rocket Like a Hurricane. And I guess we did rocket like a hurricane because the satellites were deployed successfully and they're currently undergoing commissioning. So really excited to already have a couple of constellation satellites in orbit. But as I'll talk about in just a little bit, we actually have had a test satellite up there for a couple of years, which will allow me to show some really good examples of what we can expect from the full constellation. So how does TROPICS actually achieve such high temporal resolution? Well, the key here is in the orbital configuration. We're going to have 4 satellites in a 30-degree inclined orbit in 2 different orbital planes. And so it's kind of like a trim orbit. It really focuses on the tropical regions of the globe. And there's going to be a 2,200 kilometer wide swath that will provide data up to 35 to 40 or so degrees latitude, but with a caveat that as you go to higher latitudes, you get to higher scan angles, and that decreases your horizontal resolution. But the beautiful thing about this is that the revisit rate for TROPICS actually maximizes in the 15 to 20 degree latitude band. And that, of course, is where your tropical cyclones tend to form and intensify. And so in that band, you can actually expect even better than 60-minute median revisit rate. So we're really excited about the potential for TROPICS to be able to enable tropical cyclone analysis and forecasting. So on the top left here, you can see an example of a couple of orbits, and those colored semicircles are our ground stations that we can use if we want to get low latency for the constellation, which I'll talk about in a little bit. So what data products will TROPICS provide? So there, like I said, there's 12 channels. There's a couple of imagery channels, one at 91 gigahertz and one down at 205 or up at 205 gigahertz. And we have temperature profiles in the 115 to 118 oxygen absorption line and humidity profiles around the 185 to 190 water vapor absorption line. And so you might notice that TROPICS high frequency channels are pretty similar to other microwave radiometers. That 91 gigahertz is kind of comparable to the 88 to 89 we have from other microwave sounders and imagers. The temperature channels are kind of interesting. It's analogous to AMSU's 50 gigahertz temperature channels in that 115, but the nice thing is that 115 to 118 gigahertz range actually allows us to have better horizontal resolution for the temperature retrievals, which is really nice. So you may notice that there's this 205 gigahertz channel. This is brand new. We've never had a 205 gigahertz imager on orbit, and it's showing a lot of promise. It's sort of similar to the 183 gigahertz we have from some other sounders, except the 205 is much more sensitive to scattering by large ice particles. So you're able to see some cirrus clouds, and you're also able to see regions of deep convection, which is really helpful for actually analyzing convective features in tropical cyclones. And we'll see that in a little bit. You also may notice that TROPICS does not have a lower frequency channel such as 37 gigahertz. I know this is a big disappointment for tropical meteorologists like me, but unfortunately there's a trade-off. You require a much larger antenna to get 37 gigahertz. For example, GPM's antenna is 1.2 meters in diameter, and you can't really attach a 1.2 meter dish to a loaf of bread, right? So there's a trade-off here between the temporal resolution and maybe not getting all the channels that we want. But that 205 gigahertz channel shows a lot of promise in actually analyzing convective structure in TCs. And although it's going to be lower resolution than maybe what you're accustomed to from microwave imagers like GMI or ANSR 2, it actually is going to be a little bit higher resolution than current microwave sounders like ATMS and much higher resolution than AMSU. So improving on that at least. So I mentioned earlier, we actually have a satellite already in orbit, and that is the TROPICS Pathfinder. It was launched almost 2 years ago, and we have exceeded 10,000 orbits. And the Pathfinder vehicle, which you can see there on the left, is nearly identical to the 4 satellites that are going to be in the constellation, but it's in a sun synchronous orbit. And I'll show some examples of some of the data we've gotten in a little bit. But the really nice thing about Pathfinder is it's allowed us to test everything involved with the mission and do a low latency experiment that was funded by NOAA, so thank you for that, back in April 2022 that demonstrated we can successfully implement low latency operations for TROPICS. So here's an example of what some TROPICS Pathfinder imagery looks like. The top 2 panels are the 91 gigahertz imagery, the bottom panels are the 205. And just a few things to point out here. I mean, it looks a lot like what you would expect from a typical sun synchronous microwave radiometer. You have a couple of tropical cyclones out here in the Atlantic Ocean. This is September 8th of last year. And you can also see sort of some, if you look at the individual orbits, you can actually see a little bit of cooling along the edges of the scans, and that's typical and expected in We're working on limb correction algorithms for that. But the main take home here is that it looks like kind of like what you would expect. So what I'm really excited about personally and excited to show to this group is the potential to use this new 205 gigahertz channel to actually get structures in tropical cyclones. So I'm just going to show 3 examples here. We have a lot more examples than this, but these really stick out to me personally. On the left here is Super Typhoon Mindul from 2021. The leftmost panel is the 183 gigahertz image from ATMS, which is more sensitive to water vapor. And here on the right is the 205 gigahertz from TROPICS, which is more sensitive to the ice particles. So you can see TROPICS is able to resolve the eye wall here. Certainly you can see the eye, some of the inner rain bands, and also the outer rain bands. It's able to pick up on that deep convection in those regions. Same thing with Hurricane Ian here. Compares favorably to ATMS. You can see they're resolving a lot of the same structures. One of the cool things about this, though, is you can see some of the cirrus clouds up in Ian's cirrus outflow. We're actually seeing colder brightness temperatures there because it's able to pick up on some of those larger ice particles in the cirrus. And one thing I think is really cool is if you look down here on Cyclone Emnati from last year, this is down in the Indian Ocean. The 205 gigahertz is actually able to capture an eye wall replacement that occurred in Emnati. And one thing I want to point out here is Emnati was a small TC. This is the northern tip of Madagascar right here. And the fact that it was able to resolve this little pinhole eye, you can see the red dot, and then the primary eye wall, and then the moat, and the secondary eye wall. That's pretty cool. So we're going to be able to use the TROPICS 205 gigahertz to detect secondary eye wall formation, eye wall replacement. So certainly relevant to this group, considering that it's a lot of operational forecasters. What's the latency that we can expect? One thing it's kind of typical with these NASA Earth Science Pathfinder type missions is that latency is a lower priority. But the great thing is we've been able to secure some funding from NOAA to test low latency operations, and we actually got some funding from the Office of Naval Research this year to provide low latency for the Tropics Pathfinder for this hurricane season. So right now, the latency for the Pathfinder is about 45 minutes, so it's really helpful, really useful. And we're also working to incorporate some of the lessons learned and apply those to the full constellation so that maybe for the full constellation, we can bring all these ground stations online and provide low latency data for the constellation. I wouldn't count on it for this year, but maybe for next hurricane season, we can provide some of those low latency data. So the main point here is that the Pathfinder analysis does indicate that the low latency mode for the constellation is actually very manageable. And so there's a lot of promise there. So I talked about the level 1, we call the level 1 brightness temperatures, but we also have some level 2 products that are currently under development for tropics. Like I said, they're still under development, so there's still more work to do. But the great news is that the preliminary results look really promising. This, for example, is a year's worth of mean daily precipitation on the top from MHS using the GPROF algorithm, and on the bottom using the PRPS algorithm using the Tropics Pathfinder. And you can see that they're showing very similar structures in global rainfall. So that's a really promising result. And we're also going to have a couple of tropical cyclone intensity algorithms that are going to be provided as level 2 products from Tropics. First one is the hurricane intensity and structure algorithm provided by CIRA. So thanks to Galina Chirikova for providing this chart for me. Many of you are probably familiar with these vertical cross-section plots that have been produced in the past using ATMS and AMSU. You've got your temperature anomaly and your gradient wind. And they're going to use Tropics for this as well. And again, the nice thing is that Tropics does provide the higher horizontal resolution temperature soundings, which potentially can provide even better data here. If you're not familiar with the products, maybe you can take a screenshot or copy down that link right there. You can actually view these in real time on CIRA's website. And so you can see they provide a variety of things, including TC intensity and structure information, and that's also used by SATCOM. Along with that algorithm, a nice thing is you can actually get some of the vertical structure of the winds as well. So this is just showing an example of from Hurricane Teddy. And you can see that this is the upper level winds here, 200 millibars going all the way down to 850. And you can actually retrieve some information about the vertical structure of the winds and TCs from this algorithm as well. And the second intensity estimation algorithm is TCIE, developed by SIMS. So thanks to Derek Herndon for providing this for me. And the early results for this are really encouraging. This is a scatter plot from a couple of years worth of tropics data, comparing the TCIE estimated central pressure to aircraft reconnaissance central pressure. Well, you can see here, there's a pretty good correlation, although there is a tendency to underestimate intensity for storms with small eyes, which you would kind of expect given the resolution of the instrument. But we do think that as more satellites come online, that could be improved. And SIMS is also working on a deep learning based technique to extract two-dimensional wind field from passive microwave and geostationary imagery, and they also plan to incorporate tropics into this as well. And so not only is tropics going to provide the imagery, to assess TC structure, they'll also go into these algorithms that are going to provide a little bit of guidance for TC intensity and structure as well. All right, so how can you view tropics in your AWIPS workstations? This is an ongoing project that's been led by Galina Chirkova, Mark DeMaria, and Deb Molinar over at Sierra. Really appreciate all the work that they put into this. They have been able to successfully get tropics pathfinder data into AWIPS format. Right now they're producing 91, 183, and 205 gigahertz imagery. But they also have ATMS for 88 and 183 gigahertz. So you can see some examples of these displays in AWIPS, ATMS on the top and tropics on the bottom. And they are working right now. They've got this into operations at JCWC, and they're working with NHC right now to try to get this into operations there. Those are the top priorities. But once we have that down, we're figuring out the best way to distribute the data to other locations as well. So if you're at another national center, or if you're at a local WFO and you're interested in getting tropics data into your AWIPS workstations, please contact me. My email will be toward the end of the presentation, and I'll just start making a list of people that are interested in the data. We can't get anything to you right now, but once the data from the constellation is kind of online, we expect we can start to do that. So keep your eyes peeled for that. Shoot me an email so I know to contact you when we have more information. And I did see that Galina and Deb are online. So if you have more questions about that, I can try to answer them, but at least they can maybe address more of those. So great work by them to get that going. In the meantime, if you can't access it in AWIPS, there are other ways to access the data as well. Many of you are probably familiar with NRL's TC Web portal, but they have actually developed a new user interface that I think is nice and easier to use, a little bit easier to use than the old one. This is the new URL right here. I'll just note that this is still under development, so if you encounter a few bugs, that's kind of expected. But the nice thing about this is you can actually select a year, a basin, a storm, and you can select your platform. So Tropics 1 is the Pathfinder, and TMS is the Tropics Microwave Sounder, and then 204.8 is the 205 gigahertz channel. And if you select that, it will show all of the images from the overpasses over this particular TC right in front of you on one page. And that's going to be really helpful for once the constellation comes online, because we're going to have so much imagery when we have that high revisit rate. So this could be really useful as well. If you want to take a deep dive into tropics data using the actual NetCDF files, you can grab those from the JESDISC DAC. We have a few months worth of data from the Pathfinder available on there now. And I'll also highlight you can provide, if you want to take a really deep dive, you can look into the ATPDs. You can also look at the tropics user guide as well to give you a little more information on the actual instrument and how it performs. And finally, we do have an early adopters program for tropics. And a couple of benefits of that are you will get more data more quickly. So we have a lot more data available to the early adopters than we currently have at the JESDISC. So if you want to take a closer look at some of the more recent data, becoming an early adopter is a great way to do that. We also have bi-monthly telecons, which I'll probably increase to monthly once we get the constellation online. That just gets research updates and algorithm updates from the mission science team and the stakeholder community. If you want to become an early adopter, you can send me an email. That's my address right there. I'll send you a short application and we'll get you aboard. And also, if you have questions or if you want to get on that list of potential AWIPS workstation integration go ahead and send me an email there too. So finally, some of you I'm sure are familiar with NASA sports training that we've done in the past. I've got an example of the Air Mass RGB there on the left. We are working to develop some quick guides like that, like a front and back PDF for Tropics products. We're also planning to do some short video lessons that will give some high-level highlights of the utility of the Tropics data, some of the strengths and weaknesses, and some good use cases. And if there's interest in longer format training that dives more deeply into some of the products, just let me know. We are happy to work with, there's RSET at NASA that we're starting to work with to develop some of those longer format trainings. We're also happy to work with folks at NOAA too. If you'd like to have a hand in that, we're certainly open to collaborating. So I can stop it there, and I'll mention that we got another launch going up probably sometime later this month. And so the next 2 Tropics satellites will be coming to a store near you. And I'll stop and take questions and comments. And again, there's my email address if you want to get in touch. Thanks.
Great, thank you, Patrick. That was a great presentation. I want to encourage everyone to stay on for the discussion here. And Emily is going to be dropping a link into the chat for feedback on the Satellite Book Club series. So please complete that. I also want to mention that next week, a week from today, on Thursday, May 18th at noon, Joseph Patton from CSS will discuss recent geostationary lightning mapper observations of bolides, bright flashes from meteors. And I also want to encourage you again to contact the TOWER-S team, Kashad Bowman and Emily Maddox, for questions about the Satellite Book Club or for configuration of satellite products. So I guess we'll go ahead and get started on questions. As you guys can see, we're actually at the Hurricane Center with Kashad and Emily this week. It's great to have them here with us. We're actually sitting in our hurricane and ocean test bed. That's the room you see behind us, and we have a lot of our forecasters and technical staff sitting here watching the presentation as well. So I guess first off, I'll start off if there's any questions in the room. If not, I saw there were some online. None in the room, okay. So the first question, Patrick, was from Daniel asking about if you can speak to why 3U CubeSat buses were chosen versus a slightly larger bus. Given the 3 orbital planes for the 6 spacecraft drove more or less dictated launches, it seems like you would have had excess mass and volume capacity for flying larger buses. Curious if there's an architecture lesson learned you could share here for future payload developers thinking about using small sats and unique orbital planes like this.
That is a really good and interesting question, and I wish I had a good answer for you. Those decisions were made before I was on the mission, and so I will have to ask Bill Blackwell, who's the mission PI, unless there's anybody else from the Tropics science team that was involved in that decision on the call right now that can speak to that. Yeah, I'll just have to say I'm not sure. So I'll write down your name, Daniel, and see if I can get a good answer for you.
All right. Another question I had, Patrick, could you speak to how long the mission is for these constellations or what they're designed to the lifetime to be?
Yeah, so it's fairly typical for these NASA missions to have 1 year of operations, right? And we know that if a mission is successful, a lot of times it'll get extended. So Tropics is a 1-year mission, but there have been plenty of other missions that have been short time periods that have extended to much longer time periods. A great example of that is TRIM and a lot of other satellites as well. So obviously we can't make any promises as to if it will be extended beyond that 1 year. But I would say, if the mission is performing well, I think we have a good chance of continuing to get that extended.
Okay. We have another question from Mark DiMaria Roland. If all goes well, when will the commissioning of the satellites be completed and data will go live?
It's a great question. So to give you some context, our first flight images from the Pathfinder took a couple of months to get out from after launch because it takes some time to commission the payload and do some calibration and validation. But because we've already done that for the Pathfinder, I expect it'll be a little faster for the Constellation. And so, there are a number of steps that are taken to basically go through different data maturity. So to get provisional data, I'd say within a couple of months. To actually get validated data that we're comfortable releasing to the general public, it might take a little bit longer than that. So I'm hopeful that by the peak of this Atlantic hurricane season, we can have some imagery from the constellation, but sometimes things end up taking a little longer than expected, so I don't want to promise that.
Okay.
Okay, well,
Who else has a question? You can talk from there.
yeah, it's okay. I'll stand up so you can see me. Hey, Patrick. So the kind of a follow on from the last question, in terms of the latency, so like if by the peak of the hurricane season, imagery is available, like what will the latency be, and when might the lowest latency data be available?
Yeah, it's a good question. So the Pathfinder latency is going to remain around that 45-minute mark. For the constellation, I'm not sure the latest numbers, but we need a little bit more money to make that happen. And so we're working on that. But for now, that latency is going to be up closer to that 3-hour mark that we were at with the Pathfinder before we got the low latency augmentation. There may be times where the latency is lower, and there may be times where the latency is higher. That's kind of an average value because the constellation, without the low latency funding augmentation, we can only afford to use one downlinking site. And so it can be considerably higher. So we'll keep you updated on whether we can get enough funding to decrease that latency value. But for now, it's going to be closer to that 3-hour.
Okay. I'll ask one question, Patrick. How do you expect that 205 gigahertz data is going to be used outside of tropical cyclones?
Yeah, that's a really interesting question. It's certainly valuable for deep convection anywhere that it occurs, right? So you can imagine places like monsoonal disturbances, monsoon trough, things like that. Basically anywhere there's deep convection, and that 205 gigahertz should be, you should be able to use that over land. You should be able to use it in areas where there's not good radar coverage. A use case that I like to highlight is that, if you're at the WFO in Key West and you've got some deep convection off the coast, but it's just outside your radar range, it can provide you a little bit of a better view of where that deep convection is located and where it's, where those convective cores are and how they're evolving, especially with the higher temporal resolution from tropics. So that's a use case that I like to highlight, but anywhere you want to see deep convection.
Okay. Any other questions in the room or online?
I'm just wondering what the lower limit is for the latency. Like, how low can it go if we theoretically?
That's a great question. I think that was Josh. Hey, Josh. That's a great question. I think that 45 minutes is about as low as we can get it, because in order to get data from the satellite, right, you've got to pass over a ground station, downlink it, send the data over the internet from South Africa or wherever the ground station is to the payload operations center, and then it's got to go to the data processing center, and you got to run all the algorithms on it. So that 45 minutes is probably the best that we can do.
Okay. If there are no more questions, I will go ahead and turn it back to Brian.
All right, thank you very much, Stephanie. And I did have just a couple of questions. I'm not sure they were fully answered. I'm sorry if they were. And Patrick, could you talk a little bit about the selection of the choice of the orbit for the Pathfinder in a different orbit relative to the main series that recently launched?
Yeah, good question. So the reason that that was launched as a sun synchronous orbit, primary reason was that it was on a SpaceX rideshare. And so the Pathfinder mission was funded by MIT, and it wasn't even a part of the mission requirements. So they did provide some funding to do that. And the cheapest way to get a satellite in orbit right now is to put it into a polar orbit on a ride share, because a lot of people want to go to polar orbit and not a lot of people want to go to a 30-degree inclined orbit. So that was the reason that decision was made.
Okay, very good. And the second question is, I believe you said that the microwave radiometer doesn't have a microwave band in the 30s gigahertz.
Yeah.
And yeah, you touched on this a little bit, but I was unclear on the extent to which you are looking at opportunities when there's satellite crossover to look at using the full set of the CubeSat bands that you have, supplemented potentially by bands from either ATMS or AMSU or others that offer bands in the 30s. Have you looked at that, and anything you care to say about it?
So I haven't personally done any of that work, and I'm not sure who's doing it on the science team, but there's certainly some work being done to find where those overpasses occur at the same time, both for kind of intercalibration, but also for, like you were saying, if you can find those places where complementary satellite bands are, two satellites with complementary bands are overpassing at the same time, you can get a lot of good information. So that's definitely something that's going to be done. So just keep your eyes out for that.
Okay, thank you very much. Well, appreciated this talk for many reasons. It seems to be part of a larger, or may feed into a larger discussion about what should form the future backbone of the polar orbiting constellation, and what's the right balance of major workhorse satellites as we have today with JPSS and CubeSats. The answer is almost certainly both play into it, but maybe there'll be some discovery along the way that helps answer that important question. So what a great talk, and very timely that your launches had just taken place. So thanks very much, Patrick. We appreciate it. And Stephanie, thank you as well. I want to thank you and all of your coworkers there at the Hurricane Center and your facility who hosted us today, who hosted Kaushad and Emily. We appreciate that. Book club on the road every month or so. And with that, I think we'll wrap it up. As Stephanie told us, please rejoin us a week from today when Joseph Patton will speak to us about bolide detection with GLM. You won't want to miss that. So come back. There it is, right on the screen, a week from today. And we look forward to seeing you again. Thanks, everyone, and see you next time.